Hello everyone. Today let's study hyperemia and congestion. Both hyperemia and congestion refer to a local increased volume of blood in a particular tissue. The difference between them is that hyperemia is an active process in which arteriolar dilation results in augmented blood flow, whereas congestion is a passive process resulting from decreased outflow from a tissue. Hyperemia can be a physiological state, for example, in skeletal muscles during exercise, or can be an active process which is good for the host. For example, in inflammation, increased blood inflow brings leukocytes into the site of injury. The affected tissues has a redder appearance, and the skin temperature is higher than usual because of engorgement with oxygenated blood. Congestion is a passive process resulting from impaired outflow of a tissue. It may occur systemically, like in heart failure, or it can also be local, resulting from an isolated venous obstruction. The affected tissue usually has a blue to red color, which is designated cyanosis. This appearance results from the accumulation of deoxygenated hemoglobin in the affected tissue. Congestion of capillary beds is closely related to the development of edema, and long-standing congestion further leads to chronic hypoxia and capillary ruptures. Capillary rupture causes small foci of hemorrhage, and phagocytosis of erythrocyte debris may result in the accumulation of hemosiderin-laden macrophages. Organs which are most likely to be affected by systemic congestion are lung and liver. The cause of pulmonary congestion is a left heart failure. In case of left heart failure, the intracardial pressure of left heart is increased, which hampers the backflow of pulmonary circulation into the left atria. Differently, any disease that results in right heart failure can lead to the congestion of liver. Here, we will study pulmonary congestion and hepatic congestion one by one in the following. In acute pulmonary congestion, affected lungs have a deep red appearance and are much heavier than usual. There can be bloody fluid oozing out on sectioning. Under the microscope, acute pulmonary congestion is characterized by dilated alveolar capillaries engorged with red blood cells, and there can also be intra-alveolar edema fluid accumulation. In chronic pulmonary congestion, the texture of lung becomes firm, and the lung shows up rusty discoloration at gross level. Under the microscope, we can see that the alveolar septum becomes thickened and fibrotic. In the alveolar spaces, characteristic hemosiderin-laden macrophages can be found. These macrophages are designated heart failure cells. As I have already mentioned, the other vulnerable organ of systemic congestion is liver. Right heart failure leads to delayed emptying of the great veins, and eventually the retention of blood, primarily in the central vein of the liver. This results in the dilation of central veins and pooling of blood in the sinusoid towards the center of the liver lobule under microscope. In chronic hepatic congestion, the central region of hepatic lobule has a red to brown color, indicating the congestion, and sometimes is a little bit depressed due to necrosis of hepatocytes. The region of lobule is less congested and undergoes only fatty changes, thus has a yellowish color. Altogether, these changes endow liver cutting surface a nutmeg-like appearance, which is called nutmeg liver. Under the microscope, characteristic changes of liver with chronic congestion are centrilobular necrosis, together with periportal fatty changes. Sometimes, with long-standing congestion, necrotic hepatocytes are replaced by fibrosis. That leads to congestive liver cirrhosis. Thank you, everyone. The class is over here.